The distributive property. Sorry. So to distribute something means to spread it out or to share it. And normally we like things to be distributed evenly, if possible. The distributive property has two main uses, and pretty much you'll almost always use rule number one in this list as far as your math classes. To distribute a coefficient when there are variables involved. Now there are some things I could teach you in May another time where you can use the distributive property as a way to do mental math a little easier. But today's focus will be on number one. So the distributive property is used when you have a term outside parentheses, meaning it's multiplying the parentheses, and you're either adding or subtracting inside. So let's say Alice, Ben, and Chayla are three friends. Ben and Chayla are already inside the party. The parentheses represent the party, the house where it is. So if A comes into the party, walks into the house, and B and C are already there, Ben and Chayla, it would be rude for Alice to only talk to Ben and ignore Chayla. It'd also be rude for Alice to walk in and talk to Chayla and ignore Ben. So I call this the party rule because at a party it's polite to talk to everybody. Introduce yourself to both people. So if you have A times B plus C, you first do A times B, then you just imitate the operation inside plus A times C. And if you're subtracting, A times B minus A times C. But I want to emphasize we only use this rule when we're either adding or subtracting inside the parentheses. If we're multiplying or dividing instead, we don't need the distributive property. It's only used when we're adding or subtracting inside the parentheses. Now, for 1 through 4, there are other ways that you can solve these. You could just use the order of operations. For example, on number 1, you just say, okay, in the parentheses, 12 plus 4 is 16. 16 times 5 is 80. That's fine. On number 4, you could do 9 minus 2 is 7. 7 minus 4 is 28. So from other than in this lesson, if you want to do the order of operations instead, when the only thing you have are numbers, that's completely fine. But for today, so we get some good practice with the distributive property, we're going to use it. So it works just fine on these. I'm just saying we don't have to use it on these. So we do 5 times 12 plus 5 times 4. And that gives us 60 plus 20, which is 80. And if you remember, that's the same thing we got using order of operations. 12 plus 4 is 16. 16 times 5 is 80. So both methods work. It's just that the distributive property isn't required to be used for these. Now, on number 2 and number 3, I wrote them this way to make sure you know the property works the same way whether the thing you're multiplying by is on the left of the parentheses or on the right of the parentheses. It makes no difference. It works just the same either way. So we do 8 times 20 minus 8 times 3. 8 times 20 is 160. 8 times 3 is 24. When we subtract those, you get 136. Number 3, 4 times 6 plus 4 times 3. 4 times 6 is 24. 4 times 3 is 12. You get a total of 36. On number 4, 4 times 9. Sorry, let me write it out. You don't have to write this step out, but I'm going to for this lesson. Minus 4 times 2. 4 times 9 is 36. 4 times 2 is 8. So what I was saying is you're not required to write this line. If you want to jump straight from the problem to this line right here, that's completely fine. I know you can do multiplying in your head, no problem. 36 minus 8 is 28. Again, though, if you look at what I said the purpose was, or the main use, is to distribute when variables are involved. So it works when there are no variables involved just fine. But as we do 5 through 8, these are times where the distributive property has to be used. We can't just say, oh, I'll use the order of operations and do it that way instead. We can't this time because what's in the parentheses are not like terms. 2x has an x, 3 does not, so we cannot combine those two. So our only option is the distributive property. Same down here. This has a y, this doesn't, so we cannot combine those two. Our only option is the distributive property. We follow the same steps we did before. We do 5 times the first one plus 5 times the second one. 5 times 2x is 10x. 5 times 3 is 15. And that's our final answer because 10x and 15 are not like terms. This has an x, this doesn't, so they're not like terms. So the answer is 10x plus 15. Okay, number 6, negative 6 times x minus negative 6 times 4. So that gives us negative 6x minus negative 24. Now this answer technically is correct, but it's best to not leave minus a negative. Remember, keep, change, change. So that actually turns into a plus 24. So I would count this one correct, but this is the better way to write the answer. Okay, number 7. We distribute the 6 times y plus 6 times 10. And again, there's no like terms, so our answer is finished. Last one, 4x times 3x minus 4x times 5. Okay, and I want to make sure I go through this part slowly because I know this threw some people off. 4 times 3 is 12. That part didn't throw them off. We've covered the 4, we've covered the 3. So what that leaves us is x times x. Anything times itself is the same as squaring it. So x times x is the same thing as x squared. 4x times 5, 4 times 5, we get 20x. Now these are also not like terms because this has a squared and this does not. So I want to briefly try another way to explain, make sure you understand why x times x is x squared, then I'll close. So one way you can think about it, we had 4x times 3x. Those are all being multiplied together. We could say this is 4 times x times 3 times x. And with multiplication, you're allowed to write things in any order you want to. So I could rearrange it so the 4 times the 3 are together and the x times the x are together. So 4 times 3 is 12. X times x is x squared. So if you want to write it that way, you can. Or just reminding you what squared really means. 3 squared means we do 3 times 3. We multiply 3 by itself. 5 squared means 5 times 5. We multiply 5 by itself. So the same way x squared means x multiplied by x. So that's why we can change x times x to x squared.